All right, let's take a look at number 4 here. And there was a mistake in the quiz. In the original quiz, it had, right here, it had n equals g squared minus g. But it should have been g equals n squared minus n. And so g, it says there's going to be 132 games. So g equals 132. And then n squared minus n. So to solve this, we want to first subtract 132 from each side. That gives us 0 equals n squared minus n minus 132. And now we're just looking for, since this is a relatively simple one, we're looking for a product that equals negative 132, and the two numbers that multiply to be negative 132 add up to be negative 1, because there's really a 1 right there, even though we usually don't write it. And if through some trial and error, eventually you should figure out that it's minus 12 and plus 11. You can double check that. Negative 12 times 11 is negative 132, and negative 12n plus 11n is negative 1n. So now we just set each factor equal to 0. And we get n equals 12 as one possible solution to the equation. And n equals negative 11 is the other one. But in this context, n is the number of teams, and so a negative number of teams doesn't make sense. So n equals 12 is our answer. So that's number 4. Let's take a look at another one. Okay, here's number 6. The height of a rocket can be found by using the equation h equals 180t minus 16t squared, where t is time in seconds after the launch. At what time does the rocket reach 464 feet? So 464 is a height, so we're going to put 464 in that position in the equation. So instead of h, I'm going to write 464. Then I'll write the rest of the equation. And like we did before, let's subtract 464 from each side to get a 0. Now let's put this in descending order before we do anything else. So I'll put the negative 16t squared as the first term. And then plus 180t minus 464. And before I go any further, it looks like there might be a greatest common factor. So let's try factoring out something. And through a little bit of checking, it's not too difficult to realize that negative 4 is a GCF. And notice that I'm not just factoring out 4, I'm factoring out negative 4 because the leading coefficient right here is negative. And that'll just make it a little easier to work with my getting rid of that negative as a leading coefficient. So then I have that, and I have 116. All right, my next step, let's divide each side by -4. And the reason I like to do that is it makes the equation a lot simpler. So 0 divided by -4 on the left is just 0. And -4 divided by -4 right here is equal to 1. And then 1 times all of that is just 4t squared minus 45t plus 116. Okay, at this point, we're going to need to use the AC rule. And so we're going to start by multiplying A, which is 4, times C, which is 116. And that gives me 464. And now we're looking for two things that multiply together to equal 464 and add together to be -45. And a little bit of trial and error should lead you to -29 and -16. And if you add those, they do equal -45. And if you multiply them, they do equal positive 116. So that's going to tell us how to rewrite the middle term here. So we're going to have 0 equals 4t squared minus 29t minus 16t plus 116. So now we're going to group. So if I look at the first two terms, there is a common factor of t. The 4 and the 29 don't have anything else in common, so that's the most I can do with that. Now let's look at the second two terms here, and actually we'll include the minus in that. And 16 and 116 have a common factor of, of 4. And actually -4. If there's a minus here, I want my common factor to be a negative. So -4, and then that leaves us 4t minus 29. Now before you go any further, it's a good idea to go ahead and double check by distributing. And you can see that t times 4t equals 4t squared. T times -29 equals -29t. -4 times 4t equals -16t. And -4 times -29 equals positive 116. Alright, so that tells us we factored it correctly. And we notice that there's a 4t minus 29 there, and a 4t minus 29 there. So we're going to factor that out. Write it first, and then what's left over is t minus 4. So we'll write that there. At this point, set each factor equal to 0. And solve. So for this one on the left, we start out with 4t equals 29, and then we can divide each side by 4, to get t equals 29/4, which is also 7.25. And for this other one, it's a lot more straightforward. It's just t equals 4. And so we have two solutions to the equation. And since we're talking about times, both of them actually do make sense in the problem situation. And if you think about a rocket, it's going to hit that distance twice. Once on the way up, that would be 4 seconds. And then again on the way down, that would be 7.25 seconds. So that's it for number 6. Alright, I think we have time for one more. And this is a little hard to read the text, but essentially we're trying to find this value x. And we know that the distance from the person to the top of the flagpole on this diagonal is 15, and that the height of the flagpole is 3 more than the distance from the base of the flagpole to the person. So given this picture, and knowing what I know about the flagpole forming a right angle with the ground, I can use the Pythagorean theorem, which says that the one leg, which is this one right here, squared plus the other leg of the right triangle, which is this one, again squared, has to equal the hypotenuse squared. The hypotenuse is this diagonal length, 15. And don't forget to square it. Alright. So now, if I go ahead and square these things, x plus 3 squared means x plus 3 times x plus 3. 15 squared is 225. And then we'll use the distributive property. X times x is x squared. X times 3 is 3x. I'm thinking of that one. And then 3 times x is also 3x. And then 3 times 3 is 9. And we get that. So now combining like terms, x squared plus x squared is 2x squared. Three x plus 3x is 6x. And plus 9 equals 225. So now if I subtract 225 from each side, I get 9 take away 225 is negative 216. I have a common factor of 2, which I can factor out. And at this point, I'm going to go ahead and pause, and we'll pick this up with another recording.